You may think the previous analysis is too mathematical, so now we analyze a circuit from engineering as perspective. Suppose the inductance is large enough to make the current approximate to a constant. So the voltage of the load is also a constant. Then we analyze the circuit in two time segments of MOSFETs on and off respectively. This is the first subcircuit. And this is the second subcircuit. If the circuit is in steady state, then we know for an energy storage element like inductor, the energy absorbed in it in a cycle must be equal to the energy delivered by it. In the first circuit, the inductor is absorbing energy. In the second, the inductor is delivering. Now we calculate the energy absorbed by the inductor in the first. The reference direction of the voltage and the current of the inductor is associated. So the energy absorbed by it equals Us minus U time I time T on. In the second subcircuit, the reference direction of the voltage and the current of the inductor is non-associated. Then the energy delivered by it equals U time I time T off. By solving the simultaneous equations, we get U equals Us times T on over capital T. Here, T on over capital T is a duty cycle defined in lecture 53. From the expression, we can see that because the duty cycle is a value between 0 and 1, the output voltage is always lower than the input. And we can adjust the duty cycle of the MOSFET to change the value of the output voltage. Let's see another simulation about this. In the previous simulation, the input 12 volts is changed to the output of a little more than 5 volts. What's the duty cycle of the driven signal of the MOSFET? You see, the duty cycle is 50% here. Now we change it to 20% and run the simulation again. The output voltage is lower in this condition. Similarly, we change the duty cycle to 80%. Run. The output voltage is close to 10 volts in this condition. So duty cycle is proportional to the average value of output voltage. In this lecture, we've introduced how to convert AC to DC and improve the performance of DC voltage with a smoothing capacitor. We've also introduced how to use the inductor and a switch to convert high voltage DC to low DC voltage smoothly. In the following learning of the dynamic circuits, we will introduce more energy conversion techniques of the power electronics. Well, this is the end of this lecture.